Hello everyone. Today we will talk about adsorption isotherms. So what are adsorption isotherms? Simply, when temperature is kept constant and the curves are plotted between the amount of the gas adsorbed on the surface of adsorbent and the pressure, then the graph is called adsorption isotherm. Now, variation in the amount of the gas adsorbed by the adsorbent with pressure is the adsorption isotherm. These adsorption isotherms were first of all studied by Freundlich. That's why we study Freundlich adsorption isotherm. In 1909, he gave a simple relationship between the quantity of the gas adsorbed by unit mass of solid adsorbent and pressure at a particular temperature. And the relationship which he proposed was x upon m is equal to kp raised to the power 1 upon n. Now this is called adsorption isotherm equation. Here in the picture, here in the graph, we have shown adsorption isotherm where x upon m is plotted on the y-axis and pressure is plotted on the x-axis. Now here x means the mass of the gas adsorbed and m is the mass of the adsorbent. P stands for the pressure. Now three different graphs have been plotted. First at 273 Kelvin, second at 244 Kelvin and third is at 195 Kelvin. The relationship is generally represented in the form of a curve where mass of the gas adsorbed per gram of the adsorbent is plotted against the pressure. Now these curves are simply indicating that at a fixed pressure there is a decrease in adsorption with increase in temperature. Now mathematically, if we take log on both sides on the equation, x upon m is equal to kp raised to the power 1 upon n. If we take log on both sides, we will get log of x upon m is equal to log of k plus 1 upon n log of p. So taking log, we will get this equation. Now, the validity of these isotherm, it can be simply verified by plotting log of x upon m on y-axis and log of p on x-axis. So this will come out to be a straight line. This is a straight line. Now if the gas is obeying this Freundlich adsorption isotherm, then it will be a straight line. If the gas is not obeying, then it will not come out to be a straight line. Now slope of the graph or slope of this particular graph will gives us the value of 1 upon n. So slope is 1 upon n, whereas intercept here is log of k. This is actually representing y is equal to c plus mx, where c refers to the intercept which is log of k here and m is the slope. And m here refers to 1 upon n. So the value of this n, it varies. It varies between 0 and 1. Between 0 and 1. Now when 1 upon n equals to 0, x upon m will be constant. Now the adsorption is independent of pressure. But when 1 upon n equals to 1, that means x upon m is equal to kp raised to the power 1. That is x is proportional to p, means the adsorption varies directly with the pressure. Now both these conditions are supported by the experimental results. The experimental isotherms, they always approach saturation at high pressure. So that means Freundlich adsorption isotherm cannot explain it why it approaches the saturation at high pressure. So it fails at high pressure. Next is adsorption from solution phase. Now adsorption from solution phase, it can be discussed very much similar to the adsorption isotherms given by Freundlich. So it is very much similar. Solids can adsorb solutes from solution. For example, when charcoal is put into the acetic acid solution, charcoal will be adsorbing some amount of the acid. So as a result, concentration of the acid will decrease in the solution. So what are the different observations which have been made in case of adsorption from solution phase? Number 1, the extent of adsorption decreases with increase in temperature. As the temperature increases, the extent of adsorption decreases. Number 2, extent of adsorption increases with increase of surface area of adsorbent. The extent of adsorption depends on the concentration of the solute in the solution. And number 4 is the extent of adsorption depends on the nature of the adsorbent and adsorbate. So as I told that this topic can also be explained using Freundlich equation. So according to Freundlich equation, we write x upon m equals to kp raised to the power 1 upon n. But here instead of writing p, we'll be writing c, where c stands for concentration of the solution. So C is the equilibrium concentration. That is when adsorption is completed. Taking log on both sides of this equation, we will get log of x upon m is equal to log of k plus 1 upon n log of c. Now if we plot the log x upon m against log of c, we will get a straight line graph. Straight line graph. Next is applications of adsorption. So what are the different applications of adsorption? Number 1, production of high vacuum. Now if we want to create high vacuum, that can be done simply by putting a piece of charcoal into the vessel where we want to create the vacuum. Charcoal will be adsorbing the traces of air. Number 2 is gas mask. Gas mask is simply a device which consists of activated charcoal or mixture of adsorbents. So in the coal mines where there is a breathing problem because of the poisonous gases, it is used. Number 3 is control of humidity. Humidity can be controlled by silica or by aluminium gels because they are very good adsorbent and they will be removing the moisture. Number 4 is the removal of coloring matter from solutions. This we have already discussed that animal charcoal can decolorize the colored impurities. Number 5 is heterogeneous catalysis. Adsorption of reactants on the solid surface of the catalyst increases the rate of reaction. And there are many gaseous reactions of industrial importance involving solid catalyst. Number 6 is separation of inert gases. Now different gases can be adsorbed to the different extent of adsorption. So due to the difference in degree of adsorption of gases by charcoal, a mixture of noble gases can be separated by adsorption on coconut charcoal at different temperatures. Number 7 is in curing diseases. So there are so many drugs which are used to kill germs by getting adsorbed on them. Number 8 is Froth flotation process. Now low-grade sulfide ore is concentrated by separating it from silica and other earthy matter by this method using pine oil and frothing agent. Number 9 is adsorption indicators. Surfaces of certain precipitates such as silver halides, they have got the property of adsorbing some dyes like eosin, fluorescein, etc. and thereby producing a specific color at the end point. Chromatographic analysis. Chromatographic analysis. What is chromatography? It is a technique which is based on the extent of adsorption. means different substances are adsorbed to the different extent. So chromatographic analysis is based on adsorption, and this chromatographic analysis is being used widely in analytical and in industrial fields.